Good day, everyone. My topic is all about introduction of conic sections. Conics, during the classical Greek period around 600 to 300 BC, conic sections were discovered. Apollonius 262 to 190 BC produced an 8-volume work at the beginning of the Alexandrian period. The broad applicability conics became apparent on early 17th century. A conic section, or simply conic, is a curve formed with a plane intersects a right circular cone or double napcom. The resulting curve are hyperbola, circle, ellipse, and parabola. Degenerate conic is the result when the plane does not pass through the vertex. Muna siya ang kinds of conic section: the hyperbola, circle, ellipse, parabola, and the degenerate conics. This is the focus. The curves can also be defined using a straight line and a point called the directrix and focus. When we measure the distance from the focus to the point on the curve and perpendicularly from the directrix to that point, the two distances will always be the same ratio. For the ellipse, the ratio is less than 1. Parabola is 1. So the two distances are equal and the ratio of hyperbola is greater than 1. Muna siya ang picture or photo or illustration sa eccentricity. Eccentricity, that ratio above is called eccentricity. So, we can say that any conic section is all points whose distance to the focus is equal to the eccentricity times the distance to the directrix. For 0 less than eccentricity less than 1, we get an ellipse. Then eccentricity 1 for parabola. Then the eccentricity of hyperbola is greater than 1. Then the eccentricity of a circle is 0. It shows how circular the curves. Latus rectum. Latus rectum, it is not a road word. It runs parallel to the directrix and passes through the focus. Its length in parabola, it's the 4 times the focal length. In circle, in the diameter. In an ellipse is 2b squared over a, where a and b are 1/2 of the major and minor diameter. This is the illustration of major axis and minor axis. Here is the major axis and minor axis of an ellipse. There is a focus and directrix on each side. Equation: when we place like this on an x minus y graph, the equation for an ellipse is x squared over a squared plus y squared over b squared is equal 1. The special case of a circle, where radius equal a equal b, x squared over a squared plus y squared over a squared equal 1. And for hyperbola, it is x squared over a squared minus y squared over b squared equal 1. The general equation. We can make an equation that cover all these curves because they are plane curves. Even though cut off of the solid, we only have to deal with Cartesian x and y coordinates, but these are not straight lines, so just x and y will not do. We need to go the next level, and we have x squared and y squared, and also x without y and y without x. X and y together, it is x and y. And a constant term. There should do it, and each one needs a factor a, b, c, etc. So the general equation that covers all the conic section is ax plus bxy plus cy squared plus dx plus ey plus f equals 0. Mao ni ang kasagaran ginagamit sa tanan conic section like sa ellipse, sa parabola, hyperbola, ug sa circle. And from the equation, we can create equations for the circle, ellipse, parabola, and hyperbola. The end. Thank you for watching.